So today I want to continue where we left off. I want to talk about these things in Java, how to do commenting, because I haven't covered that yet, how strings look in Java, how to convert strings into numbers. There's a math set of library code that you can use to do a little bit more of complex equations if necessary, and how to do these special input-output boxes. That'll be helpful when you guys get started on the assignments. As well, just a quick review, some shortcuts that we covered in NetBeans that would be useful to you. And again, these are not part of my notes, but they're just things that will make your life as a coder a little bit easier, and they're specific to NetBeans. Using Alt and the spacebar will always bring up that thing called IntelliSense or autocomplete. So you can bring that up to autocomplete words. When the IntelliSense is up and you want to finish the word, you can either hit Enter or Tab. Either one of those will work. And it'll automatically finish the word for you so you don't have to type it. Another thing that's handy is holding down the Alt key and scrolling the mouse wheel will zoom in and out on your code. And that's just handy to take a look at your code in different ways. And then another one that we learned last week is if you just type the word S out, all is one word, and then press Tab, it'll auto-complete that system.out.println for you. And there's lots of those little sort of quick tricks that as they come up, I'll sort of mention in class. But I just want to go over those. So, okay, so here's the code that we did last week. Now, I've zoomed back on it so you can see it's not that much code. And now I'm going to zoom in. So we finished by just doing some outputs of some various variables that we had created. And we had also turned one number type into another number type. And that's called casting, when you convert, for example, integers into doubles and doubles into integers and back and forth like that. So as you can see in my code right now is something I want to cover first is how to do comments. So the first way to do comments is the exact same way you did in C#. You just put 2 slashes and anything after that is a comment. That can go on its own line of code or it can go at the end of a line of code. So those comments can go anywhere. Okay? The second way you can do comments in Java, and I'm going to do this at the top of this program, is to put a slash and then a star. Okay? So the slash and then the star. And then when you hit Enter, oops, what it does is it opens a block of comments. Okay? So this is different than a one-line comment like you do with the slash slash. The slash and the star opens a block of comments. So everything now from here to here will be a comment. So this would be a good place to do the general commenting that you need to do for assignments, of which I'll go over at a later date, but things like your name and the date and which assignment it is and my name, etc. Like that's the stuff where you'd put that. So you don't have to do it that way. You could do it just using the double slash. But slash star is really handy because when you hit Enter, you're still kind of inside of a comment block. So it's just a handy way to do longer comments. Okay? It's also a way, if necessary, if you have a whole bunch of code that's not working, like say you had a whole bunch of code here and you weren't sure that it was causing an error or not, you could open one of those comment blocks, go down further to where you need it to end, and end that comment block. Like that. Okay, so then all that code that started up here would then be commented out until there. So it starts with a slash and a star, and it ends with a star and a slash. So that's just basic commenting in Java. Okay. So that's one thing down that we wanted to cover today. Okay. Okay, now strings. Okay, so strings in Java are a little bit different than they were in C#. Okay? And you're going to notice that right away. And I hope you notice it because of something that I mentioned to you guys last week. Now, before I bring up a slide, let's create a string. And let's see, the variable we finished at, we're on F, so we'll make a string called G. String G equals, and we'll just make it a blank string. Okay, so what do you notice right away that's different about the string than, say, for example, the integer or the Boolean or the char? What's different about string? It's not blue. That's right. There's another important difference. Capital letter. The string starts with a capital letter. And what does a capital letter mean? It's a class. That's right. So strings are more complicated than the primitive. It's not technically a primitive data type. It's a more complex data type than the integer and others. Okay? But that being said, at first you can operate with it like as if it is a regular. So I'm going to output it. I'm going to say G equals G. And this will only work if I actually give G a value. So I'm going to put a word inside there. I don't know, cat. Put the word cat in there. And it'll output like a regular string. It should output that way. And that's fine. Okay? But strings are more powerful because they have built in to them properties and methods, just like I said classes will. So this is something that I'm going to just briefly show you in the presentation. But it is more than just a simple variable type. So there's stuff that you can do with strings. Basically, strings are a collection of characters. That's what they are. Okay? They come with built-in methods or built-in functions that can be useful to you for doing all kinds of stuff. Okay? You use the capital S when you create them because there is no lowercase version of string in Java like there was in C#. Okay? You can join strings together using the addition operator, or in other words, you can concatenate two strings together to join them so that it becomes one string together. And here's an example of that. We're not going to key this in. But here's some strings: surname, first name, last name, full name, right? Each one holds a value. And what I can do is I can say full name equals surname plus first name plus last name. Now, it's not doing math with them. It's not adding them up. What it's doing is just joining them together. So it's joining Mr. Lawrence and Walks together to become Mr. Lawrence Walks, right? It's joining them, okay? And so you can see here, now this thing called full name is used in my output, and I could use that to join that with other values. So strings are probably like you'd expect them to be, in the sense that they operate similar to the way they worked in C#. Okay? Okay. Now, what you're going to need to do, though, is you're going to need to be able to turn strings into their numerical equivalent. So you could give a string a value of 47. It doesn't hold the value 47. It just holds the characters 4 and the characters 7. So to do this, we use a method called parsing. Parsing of the string. We're going to do this in our example in a sec. Okay? So let's just go right to that example in our code. Okay, so let's make another string. Let's make a string h, or no, let's give it a better value. Let's call it value equals, and let's give it the number 1, 2, 3. Okay. Now, again, it doesn't hold that value. It just holds character 1, character 2, and character 3. It's just a string. It's not the number 123. Not yet. But let's turn it into that. Let's turn it into a number. So what I can't do is this. I can't just directly turn a string into an integer. Java is not prepared to do that. And if you take a look at the lightning bolt, it'll tell you that these are incompatible. It says it requires a string, but it requires an integer, but it found a string. But like I showed you last time, whenever you see a little light bulb on the side, it's possible that Java has a tip for you, and it could possibly do this for you. Okay, and I'm going to see what it does is that, which is useless. It just turned it into a string. Well, that's not what we wanted to do. What we want to do is turn value into an integer. We don't want to turn number into a string. We want to turn value into an integer. So to do that, we type the word integer with a capital I, and we don't shorthand it this time. What does the capital I indicate? It's a class, and built into classes are methods. So after the word integer, you put dots, whoops, and then you type parse int of the value. So what this line of code does, and again, for some of you, it may be just a matter of you just sort of mimicking this line of code for now. But basically what this line is saying is, take this value right here, and that value is the characters 1, 2, 3, and parse it into an integer so that it can be stored in that integer. The word parse is kind of a techie word, but it essentially means read. So it's reading those characters. It's trying to make sense of those characters. So when those 3 characters are numbers, it's reading it as 123 rather than just character 1, character 2, and character 3. Right? Like if it read these 3 characters, it wouldn't know how to make that into a number. It would probably crash on this line of code. But parsing is attempting to read those characters as if they're numbers. That's what parsing means. So let's see if it works by outputting that number. So let's S out the number equals number. Now if this worked properly, it should have converted that value into the number 1, 2, 3. So when I spit it out, it should spit out the number 1, 2, 3. And it did, okay, for me. So this is that example again of what's called parsing. And you can do it with integers, and basically you can do it with any number type. So I'm going to try it now as a double. I'm going to say double number 2 equals double dot parse double of my value. Okay, so here now I'm converting it to a double, and then I'm going to output number 2. Okay, so text can be turned into integers, text can be turned into doubles, text can be turned into other data types, but really the only 2 you're going to need are integer and double, like I said last week. You're not going to have to worry about some of those more intricate data types. So there you can see it turned it into 123.0. Okay? So that's called parsing. Previous to that, we learned about casting, where you turn one number type into another number type. This is called parsing, where you're converting text into numbers. And that's why I wanted to put this into the examples with you guys, because that way you have example in your code before you start some programming problems. Okay? So that's called parsing. Okay, so let me check our checklist here. So commenting in Java, yes. Strings in Java, yes. And converting strings into numbers, yes. Okay? But the strings in Java, like I said before, is actually just the start of some complicated code that you can get into as you start exploring what strings can do. So I have another example in the notes of how to convert using parsing. It's in the notes if you need it, okay? You can also see here in the notes an example of how to convert into floats if you ever needed to do that. There's float.parsefloat. Again, I don't think you'll need that, okay? Similar with doubles and other types of ways you can work with strings, okay? But there are other things that are built into strings as well, okay? And on this slide, I have some examples of some of the things that strings can do, okay? So here's a string. It's just a name, right? It's my name. Then I have a char called first letter. And that first letter character value is initially empty. And then what I do is I use some code that's built into a string called char at. And what it does is it pulls a character out of the string at position 0. So what do you think position 0 is in this string right here? That's right. The capital L is position 0. So what would be stored in that thing at this point would be the capital L. Here's another built-in string method. It's called .length. What this does is it counts how many characters are in your string. So it determines and gives it back as an integer how many characters are in that string, which is useful to you, right? Sometimes you want to know how many letters there are in there, okay? And then you can do things like this if you want. Last letter equals char at length minus 1. So this would actually give you the lowercase s. Because, and here's something we're going to get into when we get into further units, if the first character is 0, and the length of this thing is, I don't know, about 13, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, the space, 10, 11, 12, 10, 11, 12, 13, 14. There's 14 characters. But the S is at position 13 because it starts at 0. So that's why I do the subtract 1 there. And again, we'll get into that more when we do our unit on arrays. You'll get used to that. Okay, here's a Boolean, is the same. And here's a new name, Lawrence Walks, although this appears to be exactly the same as that. And as you'll see when you use strings, you have to use a method called .equals to determine if two strings are in fact equal. And when we do if statements, I'll go into more detail on how that works. But it's again, something that's built right into strings, okay? So strings, and this is just the start of it, have a lot of little methods built into it. And I just want to show you real quick what that looks like. So I have a string right now called value. I created it. If I go value dots, you'll see a giant list of all the methods that are built into strings. So for example, there's a way you can turn the entire string into lowercase letters or uppercase letters, or split it apart, or pull it, or trim it. And what do those things mean? Well, if you want to explore again, you can look at those things and it'll give you a little write-up up here of what each thing does, right? So I can go ends with, and what does that do? Compare to, and what does that do? And you can read the Java documentation if you want. At this point, you won't need all those fancy string methods, but just know that they exist, that there's something that you can tap into if you need to when working with strings. Okay, so strings have these built-in methods. Another thing you can use with built-in methods is some math library code. Okay, and again, this would be if you're going to do any kind of fancy calculations. Because with a little bit of code, you can basically bring up a full calculator in Java to do all kinds of fancy math. Because, yeah, we can do the simple math of addition, subtraction, multiplication, and division. But there's a built-in math library in Java that allows you to do more complicated math calculations. And there's an example of this code right here. So here's a variable called number. And I'm going to set it to -5. Then I'm going to create a variable called answer, and I'm going to set it to 0. And what I'm going to do with this is I'm going to say answer equals, and what I can use is the word math with a capital M, which means it's a class, .abs of that number. What do you think ABS stands for? Any guess? Well, you know what? Don't worry about it. Let's figure it out. Let's try this in our code. Type math with a capital M .abs. That's exactly what it is, okay? And the way you should know that, or the way you can know that, is when you take a look right here, when it comes up, when the autocomplete appears, you can read the little pop-up description of it right here. So it says it returns the absolute value of a double value. So for those of you guys who are doing the math, the absolute value is the positive equivalent of something, right? But that's just one example. Going into the math library, I can find, for example, things like cosine and tangent and arc cosine and arc tangent. And again, depending on what kind of level of math you guys are studying, these are things that you're often bringing up on your scientific calculators or your graphing calculators. They're now built into this library right inside of Java. As well, it stores the value pi right there. So you can see there, you can just instantly get the value pi like that, right? If I don't need to find pi, I can just do that. So let me try that. Double pi equals math.pi. And let me output it. S out, pi equals pi. Okay? So here's an example of the math library in action. Just by using that capital M math, I can access a whole bunch of math functions right inside of Java. And now I'm going to play that, and you can see right there how many decimal numbers it stored inside of that pi value. So that's way easier than you having to type all those values out, is you can access pi, and there's a few other math constants in there that might be useful to you. Okay, and it's all part of that math library. Okay? So again, if you look through there, there's a whole bunch of different math library things. Now you might be thinking, well, Wux, I don't really want to do a bunch of like complicated math formulas. I didn't take comp sci for that. Some of you might be thinking that. But there is something inside this math library that you may find useful in the future, especially those of you who want to do games. And that is, built into the math library as well, is the ability to make random numbers. Whoops. I don't know if you can see it right there. Random numbers. And we'll go over that either later today or tomorrow. Random numbers, which as you know are crucial to making games and stuff like that, is built into the math library. Okay. In my notes, I have some other stuff, some other examples in the notes here. For example, absolute value powers. Here you can raise something to a power. Square roots is available in the math library. The random numbers is in there. And again, I'll go over more details on random numbers later. Okay? But all that's built into the math library. Okay. I want to wrap today on variables with input and output boxes. Basically dialog boxes. Okay? The equivalent of this in C# would have been the message box. Okay? But Java also includes a message box that allows you to do inputs. It's called an input box. Okay? So we can do outputs using system.out. That's a simple way to do outputs. But there isn't a simple system.in to get inputs. There is something like that, but it's not as simple as you'd think to use. Okay? So what I'm going to switch to now is a basic output dialog box, and in Java it uses something called J-option pane to do this. Now, what I want you to focus on for 1 second is the end of that word, P-A-N-E. It's not pain, P-A-I-N. That's what I get when I teach you guys sometimes. No. Where have you seen that word P-A-N-E in a place other than computer science? Pain, P-A-N-E. No one's ever seen that word? It's where? Minecraft. What does it mean in Minecraft? What? What? Glass pane. What's a glass pane for, though? A window. That's right. For a window. So it's like a window pane. Now, what does Windows mean in the context of computers? Well, it's a company, but Windows was the name of the company, was named after the fact that it's sort of a graphical environment. So this is just sort of a hint that there's going to be some environmental graphics. The capital J at the front stands for Java. Okay, so let's try this before I bring up the code in the... So we're going to try this. I'm going to leave some space. Okay, so it's capital J. Now, it's a weird spelling. It's a capital J and a capital O. But at this point, I wouldn't worry about learning this to memorize this thing. What's a quick way I can figure out how to spell this is by holding down Control and pressing spacebar again. This is a way you can auto-complete the word, J-option pane, and I can hit Enter, and it finishes it for me. Now, what you didn't notice happen the second you auto-complete this word is at the top of your code, without you knowing this, a line of code was added. This has now been added to the very top of your code without your knowledge. Well, it is now with your knowledge. This is a library of graphical functions, okay? And graphical stuff. It's the beginning of starting to look at something graphical. But by default, Java does not have those graphics available to you. In order to bring the graphics into your program that you're writing, it needs to write what's called an import statement up here. It is adding this giant library of code to your code. It's adding all this in there. And what it's adding is this library, this class, which comes from these two other subclasses. Okay? Swing is basically, again, graphics. That's a graphics library. I'm not sure why they called it Swing. JavaX, or JavX, is what's called an extension library. That's what the X is for. It extends Java out to add graphics to it. But that line was done for you automatically by NetBeans, okay, which was nice. It just took care of a little coding for us. So I just wanted to point that out. Okay, so now we're back down here. We've got JOption pane. We put dots, and again, it brings up all the sort of things we can do with it. And it's quite a large list. But what we want to have is the words show, S-H-O-W, then capital M, message, dialog. And you can autocomplete this and hit enter if you want. Okay? And I'm just going to type that in there just to finish it up. Okay, so here's what this thing is doing. What it's doing is it's saying, this is the message I want to send, the word hi. It's a string, right? It's a message that's going to say hi. What's before it, this thing here, is something that when you get further into the course will have more meaning to it. But right now, it needs a placeholder there. And what the placeholder is going to be is this word null. What do you think the word null stands for? Don't overthink it. That's right. It means nothing. It is essentially a placeholder of nothing for now. So what I'm saying is, show me a message dialog from this library and say hi inside of it. So let's try it. Run your code. Okay, so when we run our code, we're going to get that. You're going to get the first piece of graphics down the road that we're going to get there. So it's simple, it's basic, but it is an output window that says hi, which is good. Okay. Next up, we're going to go the other way. We're going to get input from our user. So in order to get input, the input has to go somewhere. We have to get the input and put it in something. Now, when we did this in C#, we'd build like text boxes on a form, which we'll get to later. We can still do that in Java as well. But for now, we need to put the input somewhere. So let's make a string. Let's just call it input. Simple name. Equals. And what we're going to do again is put JOption pane. And again, use Control Spacebar. It'll help autocomplete it for you. Dot show input dialog. Okay. So again, I know this is a lot of code to type, which is why that autocomplete is so incredibly useful to you. Okay, so what this is saying is, similar to the other one, I want to display this in the dialog box. The input dialog does not require a null first, so it's a little bit different than message dialog. But then what I want to do is I say, I want you to show me an input dialog, and you'll see the difference with what that looks like in a second. I want you to show me that input dialog from JOption pane. What it's going to create is a little dialog box similar to the output one, like the message dialog. So it's going to look something like this. It's going to put the word enter on it, just like the message dialog did. So it's going to have that message on there. But the message dialog, all it had was a little button that just said OK. Okay? What the input dialog will also have is it'll have a little text area where the user can type in something. And then off to the side, it'll say OK, and it'll also have a cancel button there. Okay? And what happens is, whatever the user types in here, so let's say they type the word dog in here. The second they click OK, what's typed in that text box will be shot back and stored into that integer. That's what should happen. Now, we're going to test that in a second, but we should test it by seeing if it worked. So let's output what's inside this string. Let's use JOption pane to do it. So JOption, pane dot show message dialog again. And this time I'll output the input. Okay. So what I'm saying is once I store that input, I'm going to spit it right back out as output. Okay, so let's try this. And I'm going to get rid of that line just to make it one less thing to click on. Okay, so I'm going to play it. There's the input dialog. So I'm going to put cheese into my input dialog, and it gets spit right back out in the output dialog. So that tells me that I'm getting input from my user, that the input is being stored and properly processed by the computer. So I can create input boxes and output boxes. This is incredibly useful to you now. So now you can get input, you can do stuff with it, you can do math with it, you can do calculations, and you could spit it out. And you have two ways you can spit it out now. You can spit it out with a message dialog, or you can spit it out with system.out, which is a simple just output at the bottom of the screen. That's a lot right now, right? Still not as graphical as C#, but at least you can get inputs and outputs at this point. And believe it or not, I've had students build entire final projects just based on those simple input-output dialog boxes. Because as you'll see as we get more into them, you can actually put graphics inside them and stuff like that. They can get more complicated. But that's the start of how they work, okay? This is in the notes as well, so you can find the same code in the notes, okay? In the notes, I have a couple other little examples. Maybe we'll do those in a second. In the notes, I talk about how Java has these things called core packages and extension packages. That's what I was talking about with the JavX, the extension package. It also talks about the swing library, which is part of that, and how it adds that line of code to import that code into your code, okay? And then there's the example, just like the one we did with show message dialog, okay, which displays the message dialog. It then also talks about, and again, this is leading into our new unit that we're going to do after the intro unit, methods. That methods have these things called parameters, which again, you should probably have a good grasp on if you've been doing, for example, the pre-cal math. But again, we're going to cover this in a whole unit, but in the next few slides, there's some examples of variations on this that you could do. So for example, here you can add little features to the dialog boxes, like what icon it displays right here. You can change that. Some of them are built-in icons. There's even one where you can have no icon right here if you want. And then it also talks about things like the input boxes and how those work, which we did in our example as well, okay? And there's even one called a confirm dialog, which just gives you a little yes and no button. And that's it. And there's an example in there of that. But that's, again, a little bit more complicated. You can certainly look in the notes if you want to try that. I don't think you need that right now, but we can get into that later. Okay? So let's do one more quick example before we wrap up with this. Let's remake a program that you guys did last year. It was one of the first programs you did. You may remember, it's the dog age converter. If you remember, we had a dog like a pet shop. Okay? So let's do this all through input-output dialog boxes. Okay? So let's throw up a JOption pane dot show message dialog saying, welcome to the pet shop. I think it was called the Doggone Fun Pet Shop in grade 10. Okay, so I'm going to throw up that message dialog. Welcome to the pet shop. Okay, so I'm going to display that message for my user. What I'm then going to ask them for is their age. So I'm going to have a string called text, and I'm going to say JOption pane dot show input dialog. Oops. I'm going to ask the user to enter their age. Okay, let me zoom in. I can see you guys are struggling to catch up to me. So these are the two lines right here. Okay? So I'm saying, welcome to the pet shop. Then I'm making a string of text. And I'm going to say enter age. Now watch again the difference. This one is an input dialog, and this one is a message dialog. Message dialog just displays it so you can see it. The input dialog displays it so the user can type something in. Okay, anyone have a red light who's following? Anyone? Anyone? Okay. So now at this point, the user has typed in, let's say, 17. The problem is 17 is a string. We can't get a number directly out of an input dialog box. It has to come first as a string. Now, this was similar in C# when we read out of a text box, it started as a string. We now have to convert that into a number. So let's make an integer called human age, and it equals, and for this one I'm going to use integer.parseInt, and I'll take the text. So what I've done there is I've turned the text into an integer. So now whatever number they typed in the text, the input dialog box, will now be converted to an integer using that feature called parseInt that I went over earlier. And now I'll calculate the dog age. The dog age, which I'm going to make as a separate integer, equals the human age times 7. That's the equation. Very simple equation. I just multiply their human age by 7. That'll give me their dog age. And now I'm going to output their dog age. And I'll do it with JOption pane again. Show message dialog. Oops. And right here, I'll say dog age is plus dog age. Okay. So there it is. There is 5 lines of code that, in theory, should basically work exactly the same as that program you guys did at the beginning of variables back in grade 10. Should basically work exactly the same. Let's test it. Okay. So I'm going to run this code, and it says, welcome to the pet shop. Enter the age, 44. Dog age is 308. If I was a dog, I would be really, really dead. Okay,